All right, so for these first four problems, we're just asked to describe what the transformations are that are happening to the function 1 over x. So that would be the parent function. So for the first one, if you notice, we have x minus 3 in the denominator. So remember, whatever's happening with the x, we always do the opposite or describe it by the opposite. So here, x minus 3 means that it would move, let me change the color, but it's going to move to the right 3 units. And that plus 6 means that it's going to move up 6 units. Then for the next one, number 2, that fact that it has x plus 5, we would do the opposite, so it's going to move to the left 5 units, and the plus 4 means it's going to move up 4 units. Number 3, the x minus 9 implies that it's going to move to the right 9 units, and the minus 3 means now it's going to go down 3 units. And lastly, for this little section, the x plus 7 means it's moving to the left 7 units, and the minus 2 means it's moving down 2. All right, so for these, we need to find the horizontal asymptote, the vertical asymptote, and the domain of each expression. So for some of these, we're going to want to have it in factored form, but for the horizontal asymptote, remember for that, we compare the leading terms in the numerator and the denominator. So it would be x squared over x squared. Now, the fact that those x squareds cancel out, or they're the same and they would cancel out, that means that our coefficients there are just 1s. Our horizontal asymptote would be at y equals 1. And then our vertical asymptote. To find our vertical asymptote, we need to get this into factored form. So in the numerator, we'd look for two numbers that multiply together to be negative 12, that add together to be negative 1, and that would be negative 4 and a positive 3. And the denominator, that's a difference of squares, and so that would factor down to be x plus 4, x minus 4. And so if you notice, between the top and bottom, the x minus 4's cancel out. And so that means that what's left over in the denominator, after we cancel those out, that would be your vertical asymptote. So if we set x plus 4 equal to 0, we would get x equals negative 4. So remember, for a horizontal asymptote, it's in the form y equals. For a vertical asymptote, it's always going to be in the form x equals. Now, before we cancel those out, we could find the restrictions. We would say that x can't equal 4, or, we go from left to right. For that first one, we would say x can't equal negative 4. And for the second factor, if I set that equal to 0, I'd say that x can't equal 4. So now that's going to help me find my domain, because x can be everything except for negative 4 and 4. So if you think about a number line, it could be everything before negative 4, and then in between negative 4 and 4, and after 4. So it would be everything except for negative 4 and 4. So the way we would describe that is we would say from negative infinity to negative 4, and then we would have from negative 4 to 4, and then we would also have from 4 to infinity. And we would have each of those pieces would be described by those intervals. All right, x squared plus 2x over 3x, or negative 3x minus 9. So remember the rules. If we look at the leading terms here, and if the numerator is bigger, we're not going to have a horizontal asymptote. We didn't see that happen at all. We talked about it in our notes. You didn't see it come up in any of your assignments or anything. So chances are you may not see that on the final, but it's good to just remember that if you have the degree is bigger in the numerator, there's not going to be a horizontal asymptote. All right, now to find the vertical asymptote, we need to remember get this into factored form. So I notice in the numerator, I can factor out an x. Remember, that's always my first step in factoring. Look for a GCF. I can factor out an x. In the denominator, I can factor out a negative 3. And in the denominator, we don't have anything we can cancel out here. So to find the vertical asymptote, we just set the factor in the denominator. The negative 3 doesn't have an x, so I don't care about it. But if I set x plus 3 equal to 0, I would get, if I solve that, I'd get x equals negative 3. So that'd be my vertical asymptote. And again, that means that x can't equal negative 3, because if you had negative 3, we'd have 0 in the denominator. We can't have that. So our domain would be everything except negative 3. So we could say it like that. Otherwise, we could say it in interval notation. That's what we did. And even going back to the previous one, that's what we did in class. We just said what x can't equal. So I'm not even going to write this in interval notation. We can just leave it as describing what x can't equal. So even for this one, we could have said that x can't equal -4 or +4. Would have been fine for the domain. All right, let's look at number 7. So number 7, we have 3x minus 12 over x squared minus x minus 6. So for this one, if you notice, when we look at our leading terms, the denominator has the larger degree, the larger exponent there. So whenever that happens, so when we have the degree is bigger than the denominator, we always have a horizontal asymptote at y equals 0. Doesn't matter what anything else is, what the coefficients are, the numbers in front of those are. That doesn't matter. All that matters is the degree is bigger on the denominator. It's always going to be y equals 0. All right, so to find the vertical asymptotes, we need to get this in factored form. So I'm going to factor out a 3 in the numerator. And the denominator, we're going to look to see how we can factor that down. And I see what two numbers multiply together to be -6, that add together to be -1. That would be -3 and a +2. So those are what we're going to use to get our vertical asymptotes. So we would get x equals a +3. If I set x minus 3 equal to 0, I would get x equals +3. If I set x plus 2 equal to 0, I would get x equals -2. So those would be my two vertical asymptotes. And for my domain, we can say what x can't equal here. So x can't equal 3 and x can't equal -2. All right, last one for this section, number 8. We have 3x squared minus 12 in the numerator, and the denominator we have x squared plus 5x minus 6. So again, to find the horizontal asymptote, we look at the leading terms. Here the degrees are the same. If the degrees are the same, it's going to be y equals whatever the coefficients are. So we'd have 3 over 1, which is obviously just y equals 3. So that would be your horizontal asymptote, y equals 3. Our vertical asymptote, to find those, we got to factor this down. So in the numerator, I'm going to start by factoring out a 3. And then I notice that x squared minus 4, that's a difference of squares. So that factors down to be x plus 2, x minus 2. And then we still have that 3 in front. The denominator, what two numbers multiply together to be -6 that add together to be a +5? Well, that's going to be a -1 and a +6. So we use those to find the vertical asymptote. So I set the first factor equal to 0. I would x minus 1 equal to 0. I would add 1 to both sides to get x equals 1. The other vertical asymptote, I would set x plus 6 equal to 0. Subtract 6 from both sides, so I get x equals -6. Those would be my two vertical asymptotes. My domain, we would just say what x can't be. X can't be 1 or -6. But it can be everything else. All right. For numbers 9 through, well, a whole bunch of them here. So the next section, we're going to multiply or divide each of these. So the first step, before we multiply or divide, we want to get it in factored form. So for the first one, there's nothing to factor for the first fraction. The second fraction, though, I can see that I can factor out a 5. And when I do that, I'm left with, or I have 5 times x minus 7 in the numerator, and then the denominator, we just have x plus 5. And then we're going to cancel things out. So we we can cancel out the x minus 7s. And then I can't do anything. Don't say, oh, this 5 and this 5 cancels out. That would be wrong. That's going to be, if this were a multiple choice question, chances are that would be one of the distractors. That would be one of the wrong choices. And so meant to throw you off. And you don't want to get thrown off, so don't fall for that trap. We would just leave the numerator alone. 5 times 1 is 5. The denominator would be x plus 5. Because remember, we said you can cancel out factors, but we can't cancel out terms. So we would not cancel out those two 5s there, because the x plus 5, those are not factors. X plus 5 are two separate terms. Now, some of these, it doesn't ask you to do this, but we can describe what x can't be. We can describe our restrictions. So we do that by going back to what we had originally. We would say that x can't equal 7 or -5. All right, looking at number 10. Again, we're going to look to see what we can factor. The first fraction, we can't do anything. Second fraction in the numerator, we'd factor that down to be x plus 1 and x plus 7, because what two numbers multiply together to be 7, that add together to be 8, that'd be 1 and 7. Now is the fun part. We just get to cancel things out. The x plus 1's cancel out, and that's it. We can't cancel out anything else. We're left with 2x times x plus 7 in the numerator and x plus 6 in the denominator. If they did ask for what the restrictions are, what we can't use for x, again, we go back to what we had originally in the denominator. We would say that x can't equal -6 or -1, because if we had either of those, we'd get a 0 in the denominator, and we can't divide by 0. So those would be the restrictions for number 10. All right, looking at number 11. Number 11, same deal. We're going to have the first fraction stays the same. Second fraction, the denominator stays the same, the numerator. We're going to look to see what two numbers multiply together to be -4 that add together to be -3, and that's going to be -4 and a +1. All right, so now let's see what we can cancel out. The x plus 1's cancel out, and that's it. So we would just have x minus 4 in the numerator. The denominator, we would have just x minus 9. If they ask for the restrictions, they don't, but if they ask for the restrictions, remember we look at the denominators, we would say that x can't equal -1 or +9. So those would be the restrictions in our domain for that one. All right, so now this next one we're dividing. Remember, we can't divide. Instead, we need to change it to multiplication. Remember, we have that keep, change, flip. So we're going to keep the first fraction, a minus 6 over 10. Keep that. We're going to change this to multiplication. And then we're going to flip the fraction. Now I'm going to save myself a little bit of work, and I am going to factor these. So when I flip it, this one's going to be here, and this one's going to be down here. So for this one, we look to see what two numbers multiply together to be -32 that add together to be a +4. And that would be a +8 and a -4. And then going to this one, what two numbers multiply together to be 24 that add together to be -10. So you should have said -4 and -6. So -4 times -6 is a +24, and -4 plus -6 would be -10. So now we have this all set up, so we can look to see what we can cancel out. So we have an a minus 6 here and an a minus 6 over here. We have an a minus 4 and an a minus 4. We're just left with a plus 8 in the numerator and 10 in the denominator. The restrictions for what x can't equal, again, it didn't ask for that, but we can figure that out. The 10 doesn't give us a restriction because there's no x there. But for the other ones, we would say that maybe we should change that to a. We say that a can't equal 4 and it can't equal 6. All right, number 13. This is another one where we are going to use keep, change, flip because we're dividing. And so we're going to keep the first fraction, but I'm going to kill two birds with one stone. Sorry, nature lovers. Killing the birds. Bad joke. My bad. All right. What two numbers multiply together to be 10 that add together to be 7? Well, that's going to be +2 and +5 because 2 times 5 is 10 and 2 plus 5 is 7. So we keep that first fraction, and then we're going to change this to multiplication, and then we're going to flip the other fraction. So I'm going to put the 6 on top. In the denominator, I'm going to factor out a 6 because I notice that both of those terms are divisible by 6. All right, so now we get to cancel things out. My favorite part. So the 6's cancel out, the v plus 2's cancel out, and I'm left with v plus 5 in the numerator and v minus 1 in the denominator. Remember, I need to say what my restriction is in my domain. So in this case, what can't we use for v? So I look down here. So v can't equal 1. The 6, we don't get to worry about a restriction for that because there's no x with the 6. But for the v plus 2, v can't equal -2. So those would be my restrictions in my domain for number 13. All right, lastly for this section, for number 14, again, this is another keep, change, flip problem because we're dividing. So I'm going to keep the first fraction. There's nothing I can do with either the numerator or the denominator. I'm going to change that to multiplication, and then I'm going to flip. So the 6 is going to go in the denominator. The numerator, I'm just going to go ahead and factor that. That's a difference of squares. So factors be p plus 10, p minus 10. Now we are again, I cancel things out. So the p minus 10s cancel out. That's it. So we're left with p plus 10 in the numerator and 6 in the denominator. And then we got to say that even though, again, they didn't ask for it, so if you didn't do this on your own, that's totally fine, but just good to review. The restrictions, p can't equal 10, and that's it, because that's the only thing that we have in our denominator there. That's the only thing that p can't be. All right. Let's talk about adding or subtracting fractions. When we add or subtract fractions, your answers should remain a fraction. So we're not going to get rid of the denominators here. Our answers should still be a fraction. So for these, we want to figure out what's the least common denominator. Or we can say the least common multiple, same thing. Now these already have the same denominator, so we can just add these together. Now this is subtraction. So what I'm going to do is I'm going to change this before I do anything. I'm going to change this to adding, and I'm going to distribute that negative. Okay, so we would have in our denominator, we'd have 2n minus 4. Okay, so we have a common denominator, so we can write that as a single denominator. Our numerator, we'd have n plus 3. Then we'd have plus a negative 5n, so we'll write it as minus 5n, and then minus 6. Now we're just going to simplify that. So our denominator, we would have 2n minus 4. And our numerator, n minus 5n would be negative 4n. And 3 minus 6 would be negative 3. And just like we were doing before, they didn't say what or not to, they didn't say anything about restricting the domain. Let's just go ahead and do that. We would say that n can't equal, if I set 2n minus 4 equal to 0, we would add 4 and divide by 2. So we would say that n can't equal 2. All right, next one. Again, similar situation. We already have a common denominator, so that makes it a little bit easier. So our answer is going to have 6x minus 12 in the denominator. In the numerator, we would have x plus 8 plus 4x minus 10. Now we're just going to combine like terms. When you do that in the numerator, the x plus 4x, that would be 5x. 8 minus 10, that's negative 2. So we have 5x minus 2 in the numerator. In the denominator, the 6x minus 12 stays the same. And we just say what the n can't equal. If I set 6x minus 12 equal to 0, I would add 12 and divide by 6. 12 divided by 6 would give me 2 again. So n, or I guess I should have said x can't equal 2. All right, these are not common denominators, so we have to do a little bit of work for this one. So we have to find that least common multiple, which is going to be the least common denominator in the end. So our one denominator, we have b minus 2. The other denominator, we have b minus 3. So least common multiple, that's what I'm going to, or that's what I need to have as my denominator. So in essence, if I want that in my denominator, just think about it this way. I want to have b minus 2 times b minus 3 as my common denominator. So this first fraction, what are we missing? We're missing b minus 3. So we're going to multiply that first fraction by b minus 3 because we already have the b minus 2. So I'm looking at this. What are we missing? So the next fraction, we'll change this to be plus a negative 3b. But we already have the b minus 3. So I'm looking at, well, what am I missing? I'm missing b minus 2. So we're going to multiply the top and bottom by b minus 2. So when I do that, I'm just going to go ahead and, for this next step, I'm going to distribute 5b through. So we would have 5b squared minus 15b. And here, I'm going to distribute the negative 3b through. So we'd have minus 3b squared plus 6b. All right, so if you didn't catch all that, maybe pause the video and just process and figure out what I just did to get from that purple step to this what I have in red. All right, so if you've got that, let's go on to the next step. So the next step, we're going to simplify that numerator. So the 5b squared minus 3b squared, well, that's just 2b squared. And with those, negative 15b plus 6b, well, that's going to be minus 9b. And our denominator is b minus 2 and b minus 3. If we had to give the restrictions what b can't be, we would say that b can't be 2 or 3, because those would be in our denominator. That's what would give us zeros in our denominator. We would not want that. So those would be my restrictions. All right, let's look at number 18. For 18, let's start with the least common multiple, LCM, because the LCM is what we're going to have in our denominator. So I look at the first denominator, we have x minus 5. The second denominator, we have x minus 3. So those are our only two factors in our denominator. So that's what we're going to have as our answer for the denominator. That's my goal. So I need to look at my first fraction. Okay, so I have x minus 5 here. What's missing? X minus 3. So we're going to multiply the top and bottom by x minus 3. Let's look at the next fraction. What do we have? We have x minus 3. What are we missing? We're missing x minus 5. So we're going to multiply the top and bottom by x minus 5. So I have my denominator, which is what I wanted, x minus 5, x minus 3. Now let's simplify the numerator. So I'm going to distribute the 6 through. So 6 times x, that'd be 6x. 6 times negative 3, that's negative 18. Then distribute the 5 through. So we'd have plus 5x minus 25. Okay, so now I'm just going to combine like terms in my numerator. So we're going to have our denominator is going to be x minus 5 times x minus 3. Our numerator, 6x plus 5x, well, that's 11x. And negative 18 minus 25, if you need to use a calculator, you can. You get negative 43. And they don't say this, but if we wanted to find the restrictions, we'd say x can't equal 5 or positive 3. Because those values would give us 0 in our denominator. We do not want 0 in our denominator. All right, so that was adding and subtracting fractions. Now let's look at solving equations. Okay, so that's what we're going to end on here. For 19 through 22, these are all just solving equations. So to start out with, let's factor the denominator, because our goal is to figure out what's our LCM here. And so for this one, what two numbers multiply together to be 5? That add together to be negative 6. Well, that's going to be negative 1 and negative 5. And this is going to be the same thing. All right, so I want to get, so my LCM, if I look at my first denominator, we have x minus 5. The next fraction, we already have the x minus 5 listed. Then we have an x minus 1. The next fraction, it's the same thing, x minus 5, x minus 1. So the LCM is what we're going to use to get rid of the fractions. Okay, so when I multiply everything by my LCM, x minus 5 times x minus 1, again, we're getting rid of the fractions. So for that first fraction, the x minus 5 would disappear from that denominator, and this would cancel out, leaving us with x minus 1 times 3. Okay, now I'm going to go back. So the x minus 5 is gone from that denominator. So now I'm going to go back and still have x minus 5 times x minus 1. I'm going to multiply that times the next fraction. Well, for the next fraction, that means that everything cancels out, leaving us with just 1. Okay, now notice it's probably not a good idea. Now I have the pleasure of erasing after I cross out the x minus 5 and x minus 1 that I'm multiplying by. But when you're doing this on your own, you might not want to do that, because you might think, well, what do I have left over to multiply? So every single time, we're starting all over again with the x minus 5 and x minus 1. All right. Then I look in the far right. Make sure you multiply everything by x minus 5 and x minus 1. So these would cancel out with these, leaving us with just 3. So now I'm just going to solve this equation. I'm going to distribute the 3 through. So I would have 3x minus 3 plus 1 equals 3. Or 3x minus 2 equals 3 if I combine like terms. So now I'm going to solve this by adding 2 to both sides. And if I divide by 3, I get x equals 5/3. Now remember, the whole point in finding those restrictions is to find out what x can't be. So x can't equal 5 or 1. So if I were to get either of those answers as a solution, then that would be an extraneous solution. This is not in those restrictions. So that's a solution that works. It's all good. All right, for number 20, we're going to start this one again by factoring in the denominator. We don't care about factoring the numerators. If there was something in the numerator, we wouldn't need to factor that down. All we care about is the denominators. All right, so for this one, we'd factor this down to be x plus 1 times x plus 6, because 1 times 6 is 6 and 1 plus 6 is 7. The next denominator, it's the same thing. All right, so that's my LCM. And that's what we use multiply everything by, to get rid of the fractions. We don't want to have a fraction in our answer. We're solving for x. So it would do us no good to keep this as a fraction. That's the whole point in doing this, is to get rid of those fractions and just have an equation to solve. So when I multiply that first fraction by x plus 1 and x plus 6, these cancel out with the x plus 1 and x plus 6, leaving us with just 3 on the left. Same thing here, leaving us with just 1. Now here, this x plus 6 and this x plus 6 cancel out, but we'd be left with x plus 1. We'd have 1 times x plus 1, which obviously is just x plus 1. I'm just showing you that if we add a different number there, we distribute that, kind of like our previous problem. So anyways, we're going to go through and simplify this. We'd have 3 on the left. I'm just going to erase this. On the right, we would have 1 plus x plus 1, or just x plus 2. So if I subtract 2 from both sides, I would get x equals 1. That is not in our restriction, because remember, for our restriction, x can't equal -1 or -6. So having x equal positive 1, totally fine. All right, let's look at number 21. For 21 here, we are going to start by factoring our denominators. If I notice, I can factor out an x. When I do that, I'd be left with x times x minus 1. So the same thing for the second one here. We'd have x times x minus 1. So my LCM would be x times x minus 1. That's what we're going to use to multiply everything by. All right, so now when we do that, this x minus 1 and this x minus 1 cancel out, leaving us with just x times 1, or just x on the left. Going to the next fraction, the x minus 1 and x minus 1 cancel out, leaving us with 3x minus 6. X minus 1 times this next fraction, the x minus 1 and x would cancel out, leaving us with just 3. So what I'm going to do here is I'm going to subtract 3x from both sides, so I'd have negative 2x equals a negative 6 plus 3 would be negative 3. So if I divide both sides by negative 2, I'd get a positive 3/2, because negative 3 over negative 2, the negatives would cancel out, leaving us with a positive 3/2. That is not my restriction, because our restriction would be that x can't equal 0 or 1, and so 3/2 is not either 0 or 1, so 3/2 would be our solution. All right, let's look at number 22. This is the last problem in this section. And so for this one, again, we're going to start by factoring out. We have an n that we can factor out, so we'll be left with n minus 2. Okay, so that's going to be my LCM. Remember, that's what we're going to multiply by. Multiply everything by n times n minus 2. So this will cancel out with the n and n minus 2, leaving us with just 3. Remember, this is plus a negative 3, so don't forget that's a negative 3 there. So this n would cancel out, leaving us with n minus 2. So we'd have negative 3 times what was left over, the n minus 2. And then on the right side, the n minus 2s and the n would cancel out, leaving us with just 1. So now when I go to simplify this, we would have distribute the negative 3 through, so we get negative 3n plus 6. Now I'm going to combine like terms, so 3 plus 6 would be 9. And if I subtract 9 from both sides, I'd get negative 8. And if I divide both sides by negative 3, I'd get 8/3. And so that would be a positive 8/3 there. Again, that's not in our restriction. So our restriction would be that n can't equal 0 or 2. So if we had gotten 0 or 2 as our answer, those would be extraneous solutions, but we didn't. So our only solution here would be 8/3. So that's the end of chapter 4. So hopefully that made sense to you. If not, just make sure you get your questions answered from me.